Good morning, students. Welcome back to Digital Signal Processing class. As you know, I am Syed Fasiyuddin from ECE department from ISL Engineering College. So today I am going to continue the digital signal processing. In that, the first topic, the topic which we are discussing in today's class is DFT. DFT and IDFT. So what is DFT stands for? DFT stands for Discrete Fourier Transform. And IDFT stands for Inverse Discrete Fourier Transform. So basically, what is DFT and IDFT? So DFT is nothing but discrete Fourier transform, and IDFT stands for inverse discrete Fourier transform. So what is the meaning of discrete? Discrete signals. Discrete in the sense we have two types of signals. One is the continuous, another is the digital or discrete. So what is the meaning of continuous? Continuous signals are nothing but when you had one particular signal, like we are taking sine wave, it is having t with x of t function. That means at every particular interval of time it's keep on changing. That means it's a continuous in nature. So in discrete means it obeys two things. One is the time duration. For each duration the impulses will be different. So like this. So this type of signal is considered to be the discrete signal. Same I am mentioning, instead of t over there I am mentioning n with x of n. So this is nothing but the discrete signal. So what is the discrete Fourier transform is all about? Fourier transform is given by, in this discrete Fourier transform we are taking n samples, n domain we are converting into k domain samples. What is this n domain indicates over here? N indicates whatever the samples we are having, the same samples we are converting into the same function k with x of k by applying Fourier transform. Clear? So by applying the Fourier transform to these impulses, this is what actually, this is in the form of x of n. The same functions we are converting as per our requirement into different specific formats. So what is this actually? This is nothing but x of n, it is in discrete form. So we are taking Fourier transform, so it's nothing but discrete Fourier transform we are converting into k with a function of x of k. So that indicates this x of n function we are converting into x of k. So that we can do it by applying DFT or discrete Fourier transform. So likewise, if you want to do the inverse operation, that is nothing but reverse of it, then it is called inverse discrete Fourier transform. So how to do it, IDFT and DFT? There is a specific mathematical calculation, the formula which we need to do it. By applying that formula, we can convert your n domain signal into k domain signal or k domain signal into n domain signal. That I will show you here. So what is DFT? First thing we have taken. So DFT, if you want to find the n domain signal, we are converting into k domain signal. So that means if you had the input signal x of n, we are converting into x of k. So by applying DFT, we are converting x of n into x of k. So how do we mention that one? So DFT of x of n is equals to x of k is equals to, since it is discrete. Discrete means if you had a continuous form, if you had continuous signal, then it should be done with integration. So since we are dealing with discrete means it should take in summation. So here what we are taking? Summation, the value starting from n is equals to 0 to maximum samples we are taking as n minus 1. So what is the input function we are taking? X of n, we are taking a two-dill factor, exponential factor, or it is called two-dill factor. So exponential of e power minus j 2 pi k with domain of n by number of samples is n. So what does this indicate? This is nothing but, this is called twiddle factor. So what is this n indicates? N indicates the input value given in the function. What is this capital N indicates? It indicates number of samples. Right, so we do have n value, they'll give you capital N, we need to take number of samples, this factor we need to apply and we need to substitute in our function. So if you do have n, you want to convert into k domain, so we have to apply a DFT. So DFT of x of n can be mentioned as x of k is equals to summation n is equals to 0 to n minus 1 x of n into this particular form. So this is nothing but your DFT. So DFT of the function we can write in this way. Likewise, if I want to write the formula or expression for IDFT, so IDFT is a reverse of it. In that reverse format, what we'll do, your x of n you're converting into x of k. So over there what we'll do, we take k, we want to convert into n domain signal. So for doing this thing, what we'll apply? We'll apply x of k, we'll apply IDFT, we are converting into x of n. Right, so your k samples of that input is being converted into n domain signal. So how do we do it? In order to do these things, what we'll do, we'll apply the same function IDFT of, instead of x of n, what we have to write, x of k is equals to, so what I'll get output here, we got x of k is because we are converting n into k domain. Now it will be reverse, k domain to n domain, x of n is equals to, so we need to take a factor, that is 1 by n summation. So here input starting from n equal to 0, that will be reverse over here. So k is equal to 0 to maximum is n minus 1 because it's a finite. So we need to write the maximum sample value for it. So what we'll write, x of k e power plus j 2 pi k n by n. So that is nothing but your k domain signal has been converted into n number of samples by taking this factor. So by using these things, whatever the functions we do have, that k factor we are converting into n domain signal. So by applying IDFT, so by using this factor we can convert your input samples into a respective specific value. So by using these things, they'll give you number of samples in the question. We need to apply this formula, and what is this factor is called? Again, this is nothing but your twiddle factor. So by using this twiddle factor, we can able to convert your function into a respective function value. So let us see some problem based upon this, and we'll try to convert that value. Let us see the problem, students. So we are taking one question, obtain the DFT of the sequence x of n is equals to 1, minus 1, 0 and 1. So they gave one sequence x of n, we need to obtain DFT of this x of n. So basically what we know that when we are having DFT of x of n, so what is the DFT of x of n we can write? We can write as x of k. Right, so they gave a question over here, so we are writing the sequence x of n is equals to, what is the sequence we have, 1, minus 1, 0 and 1. So they gave these sequence. So by using this, what is the starting value? We'll write it's a position. What is the position of it? X of 0, we'll start from 0, x of 1, x of 2, x of 3. So what is x of 0 value? So x of 0 they gave us, what is the first value we have? 1. Then x of 1 is what? Minus 1. Then this is what? 0. Again we got 1. So we got these 4 values. So as per our DFT, what is the DFT formula we do have? DFT of x of n we can write as x of k is equals to summation starting from n is equals to 0 to n minus 1 x of n e power minus j 2 pi k n by capital N. So this is the formula we do have in order to convert our DFT of x of n into x of k. So next thing what we'll do, we'll try to write as per the condition. So what is this n indicates? N is nothing but number of samples. So what is the sample value is given? So 1, 2, 3, 4. So what is n is equals to? It's 4. So they gave 4 samples. So we'll take n is equals to 4 value. We do have the position value for it. So we'll substitute over there. So what we'll get? X of n of DFT is nothing but x of k. So x of k is equals to summation n is equals to 0 to, what is this capital N value we do have? 4. So it's 4 minus 1. Next, x of n. So we are writing x of n as it is, e power minus j as it is 2 pi k. So since we don't know k, so k let it be as it is, k into n, that it will be as it is divided by, what is this value of n? It's nothing but 4. So we do get this thing. So what we'll write for it? So we'll write this 2 ones are, 2 twos are, it gets cancelled. So we'll write x of k is equals to summation n is equals to 0. 4 minus 1 it is 3. So we could keep it this thing as it is, x of n e power minus j, what is this value? Pi by 2 into k n. So we got this x of k value now. So what is x of k? We formulate as per the given condition, summation n is equals to 0, n minus 1. What is this n value given in the question? 4. So it's 4 minus 1 is 3. X of n e power minus j. So we got it as n value is 4. So we're keeping that 4 as it is. 2 ones are, 2 twos are. So 2 kn. So kn is as it is. That we need to write it down. So that value we are keeping. So 2 ones are, 2 twos are. It will be as it is. So we know it. What is the value of it? We know e power minus j theta. We can write as sin theta minus j cos theta. So by using the exponential factor, we are applying this thing. Right? So here we gave the factor. We need to apply it, this factor. Before doing it, we know the value of k. We know the value of n. So we know these two values. So that value we are keeping as it is. So x of, what is the first value I'm assuming? Let k is equals to 0. That is my first value. So what I'll get over here? X of 0 is equals to summation n is equals to 0 to 3. This is my x of 0, x of n as it is, e power minus j pi by 2 as it is. What is this value k? It's 0 into small n as it is. That means this I got pi into 0. What is pi into 0? It will be 0. So I can write it as n is equals to 0 to 3 x of n e power minus j into 0. Right? So I got e power minus j into 0. What is this e power 0? Any number power 0 would be 1 because we are applying a power 0 is 1. So we got this thing. So we have this value. So what I can write now? I can write that factor as it is. So what I can write for this? I can write x of 0 is equals to, what is left over there? Summation n is equals to 0 to 3 x of n into e power 0 is nothing but 1. So we got this first number. That is my first number. So students, we got x of 0. We got, since it's what? E power 0, we can write it as 1. So that is as it is. So we got the first number. So we can write here O here is, apply the summation for this. First n is equals to 0. It is x of 0 plus next n is equals to 1, x of 1. N is equals to 2, x of 2, n is equals to 3, x of 3. So we are adding all these things. So that is our first position, x of 0. So we got x of 0 is equals to, what is the x of 0 value? This is position 0. 1, 2, 3. So x of 0 value is what? 1. Plus x of 1 is what? Minus 1. Plus x of 2 is 0. X of 3 is 1. So we got these values. So this plus 1 minus 1, both will get cancelled. So we can write, this one is answer of that will be 1. So we got x of 0 is equals to 1. That is the first value. So similarly, I can find k, let k is equals to 2 in the main formula. So what I can write over here? So k is equals to 2 in this one. This is our k condition. This is now our formula. So what is k value I am writing over here is 2. So here what is k value now? It will be 2. So I'll put over there. So x of, instead of 2, first we'll start with 1 because we took 0, right? So x of 1 is equals to summation n is equals to 0 to 3 x of n e power minus j pi by 2 as it is. What is k value? 1 into n as it is. So we got this factor. So put n is equals to 0 to 3 x of n e power minus j pi by 2. This will be as it is into n as it is. So what I can write for this? I can mention that number in terms of exponential factor. So how do we mention? We have to put all those values starting from 0, 1, 2, 3, because we had 4 samples, so we'll start from 0 to 3. So we'll put it that same number. So what I'll get for this? I'll take first x of 1 is equals to first value, put 0 both the side. So we'll get x of 0 e power minus j pi by 2 into 0 plus next number. I'll put next n is equals to 1 in this, x of 1 e power minus j pi by 2 into 1 plus I'll put next number x of 2. So x of 2 e power minus j pi by 2 into 2. I'll put it the same thing. Next I'll put x of 3. So x of 3 e power minus j pi by 2 into 3. So I put all the values. So what I'll get the first thing? I'll get x of 0. E power 0 will be 1. Similarly, I'll get second one x of 1. So what I'll get for this? I'll get e power minus j pi by 2 plus I'll get next factor x of 2. So e power this 2 gets cancelled. I can write minus pi plus this factor. What I can write for this? Here I'll write because it's not visible. X of 3 e power minus j 3 pi by 2. So we got x of 2 that we are keeping as it is. This 2 gets cancelled. Next thing is what? X of 3 into e power minus 3 pi by 2. This we kept it. Now the thing is that we need to know the x of 0 value. What is x of 0? That is the 0th position. This is 1, x of 1 minus 1, 0 and 1. So these values will substitute over here. So what is x of 0? 1 into 1 plus x of 1, it's minus 1 into e power minus j pi by 2. Next x of 2, what is x of 2? 0 into e power minus j pi. Then x of 3, we had 1 into e power minus 3 pi by 2. So we got this thing. So what we'll do it? We'll apply 1 side, it is 1. So plus into minus, it is again minus 1 e power minus j pi by 2 plus the 0 into anything will be 0 plus here we got e power minus 3 pi by 2. Now we got two exponential factors. Here is 1, here is one more. So 1 in that x of 1, what actually we are taking? X of 0 we got it as this one, and x of k, what is that problem in that one? X of k we got it as this is our x of k, right? So x of k is equals to summation n equals to 0 to 3, this one, and we got x of 1. So what is the value of this x of 0? So we need to write all those values. X of 0 is equals to 1, x of 1 is equals to minus 1, x of 2 is equals to 0, x of 3 is equals to 1. So we got these values, we know it. So put it over this thing. So what will you get? X of 0, it's 1, e power 0 is also again 1, 1 into 1 plus x of 1, what is x of 1? Minus 1, e power minus j pi by 2, left out over there. Similarly, x of 2, what is x of 2 value we had? It's 0. So 0 into anything will be 0. So we don't know need of finding this thing. This 2 gets cancelled, we'll not find out. Similarly, x of 3, what is x of 3? We do have 1 into e power minus 3 pi by 2 with j, right? So we got these all values. So we got 1 minus e power minus j pi by 2 plus this is 1 e power minus j 3 pi by 2. So let it be your x of 1. You can keep as it is, or you can apply the formula of e power minus j theta. So what is that? E power minus j theta? Cos theta minus j sin theta. This I can put it. Or directly you can keep this value in your calculator. You will get the answer of x of 1. Okay, so we got till now x of 1. We had x of 0, x of 1. Next thing is what? Put next case. K is equals to 2. So in this main equation, let it be your equation 1. In this equation, you need to put the value of k is equals to 2. So what is x of that number? K is equals to 2 means what will get this thing? X of 2 is equals to same summation n is equals to 0 to 3. X of n, because we are not putting n value, let it be as it is. E power minus j pi by 2 as it is into what is k value we had? K is 2 into n as it is. So we can cancel this 2 and this 2. So we got it. We got the number as n is equals to 0 to 3 x of n e power minus j pi n. We got this value. So what I can write? Now apply the summation for this whole number. We got it as, what is the first number we got? X of 0 e power minus j pi into 0 plus next number we do have after 0 next would be 1. So x of 1 e power minus j pi into 1 plus x of 2 e power minus j pi into 2 plus x of 3 so e power minus j 3 pi. Like this we write. So all these values we know. X of 0, x of 1, x of 2 and x of 3. Those numbers we can write over there. So what I can get this thing if I write over there? X of 0 is what? 1. E power minus 0 will be again 1. Similarly x of 1. What is x of 1 value? Minus 1 e power minus j pi plus x of 2. What is x of 2? We had 0. So x of 2, this is nothing but 0 e power minus 2 pi of j plus x of 3. X of 3 is 1 into e power minus 3 pi of j. So we had all those numbers, so we can write. So 1, this is what? Minus e power minus j pi plus this one e power minus 3 pi of j. So this is nothing but x of 2. So we found x of 0, we found x of 1, x of 2. What is left out now? X of 3, because we had the numbers from 0, 1, 2, 3. This is an n domain, we are converting into k domain. So we'll do it and we'll find out the x of 3. So we'll convert over there and we'll write the number. So here what you have put, you have put k is equals to 2 now. Now next thing is that put k is equals to 3. So we can find x of 3. In this we are putting, so summation n is equals to 0 to 3 x of n, because we don't know the value of n, that depends upon this summation. So e power minus j pi by 2 and that number is 3 into n, that we are writing. Clear? So what I can write? Now I can put the value of n's, all these things I can write over here. So put n, x is equals to 0, x of 0 e power 3 into 0. It will be 0 because I am putting n, here is also n, here is also n. That is the first one. Similarly second one, x of 1 e power minus j 3 pi by 2 plus next number put n is equals to 2, x of 2 e power minus j pi by 2 of 3, that is as it is, we are putting 2 there, plus x of 3 I can write as e power minus j pi by 2 3 into 3. Clear? So this we know it, this thing we keep as it is. We'll write this remaining value. So now tell me what is x of 0? This is your x of 0. 1 into e power 0 will be again 1 plus x of 1. What is x of 1? Minus 1 e power minus 3 pi by 2 of j plus x of 2. What is x of 2? We do have x of 2 is 0 into e power this to cancel minus 3 pi j plus this is 0. That number we put it. Next thing, x of 3. What is x of 3? We have 1 into e power minus 9 pi by 2, because 3 3 is a 9 pi by 2 of j. So clear? So we got 1 into this one e power minus 3 pi by 2 of j plus this is gone because it's a 0, so we'll not mention that, we only mention the last one. So we can write e power minus 9 pi by 2 of j, that is your x of 3. So at the end you need to write your function x of k. So x of k is equals to the first answer, x capital X of 0 comma x of 1 comma x of 2 comma x of 3. So all those answer you need to write down. So whatever the values we got, x of 0, x of 1, x of 2, x of 3, those if you write it, then your n domain x of n can be converted into k domain x of k. So clear? So the value of this exponential you put in the calculator, you will get the answer for it. So that's how we have completed our first problem, that is converting your DFT into that respective domain. That is n domain we have converted into k domain by taking the 4 samples. So what actually we have done, first thing we try to make the formula, we made it. Next thing we put different values of k. K is equals to, depends upon your number of samples. Here samples are 0, 1, 2, 3. We start from 0th position. So we got 0 to 3. That means 4 cases we need to find. When k is equals to 0, k is equals to 1, k is equals to 2, k is equals to 3. After taking this thing, we need to consider this factor, that is called twiddle factor. By considering this twiddle factor, your signal, that is x of n domain signal, convert into x of k domain signal. So thank you for today's class. In the tomorrow's class, we'll do more problems.